So good morning all of you. This is the third lecture on problem solving strategies. I hope most of you would have enjoyed my first and the second lecture. Now this is the third lecture where we'll be seeing or we'll be trying to understand different methods of problem solving. What are the different types of approaches which is going to help us solve the problems? Different textbooks have defined different strategies. As per our Board of Studies, university has recommended certain textbooks and certain methodology for our study. We will be following the university norms. Okay. Only because your answer sheets will be evaluated in different pattern. Your university examination answer sheets will not be valued by our college, will be valued by some other. We have a valuation camp after you have written your university exams. These papers will reach the evaluation camps with false numbers, and there will be different kinds of teachers. I'll be one among them, but I'll be evaluating some other answer sheets. Your answer sheets will be evaluated by somebody else. So, examination point of view, I'll be giving you some examples and some strategies which is required for you to write your exam papers. Okay, so according to the Board of Studies pattern, we'll be following for almost every question. So we'll be dealing, I'll be teaching you, I'll be giving you examples of questions and so on, but I want you to develop more by thinking and writing better answers than whatever is being taught in my class. So the first thing or the first method of problem solving defined scientifically is trial and error. Can any one of you tell me what do you understand by the word trial and error, or by the phrase trial and error? What is that going to help us solve a problem? You can see a game here, right, which most of you would have played in your childhood. You take the first piece and check whether it is getting suited into the next one, right? If this suits, your problem is solved. If it does not get solved, what you do? You take the next one and you try to insert it in the space provided. You keep repeating this process until your entire problem is solved. So trial and error means you are trying out different solutions and finding out a solution which is most suited for the problem. This method is among the first thing that you are going to study in problem solving strategies. So trial and error means trying out solutions to the problem by experimenting with different solutions. We'll find out the best or the successful solution as we keep on trying. So different solutions are being tried out until the problem is resolved. This is possible only when you have finite number of solutions. Is that okay? So in the coming slide, we'll be studying about the different steps that is being involved in trial and error method. And everything is a question. Keep this point in mind. You can get questions on generic topics, and you may not get enough marks if you keep writing something or the other. You need to write all point wise. Okay. So next one, the steps that is involved in trial and error. First step, identify the problem. Start by clearly defining the issue. When you are answering multiple choice questions, sometimes you try your luck. If there is no negative marks, you can simply click out any answer and see if it is right. Okay, solutions are given to you. The problem statement is also given to you. So it is very easy for you to try and see whether something works out or not. So trial and error method of problem solving, in most cases what we do is that once we identify the problem, we define the problem statement, then what we do is that we try out all possible solutions. We try one solution and we try to check whether this is a solution or not. If the solution is fine, what happens? Our problem is solved, right? If our solution is not fine, what we do? We go to the problem statement, we redefine the solutions, we try the next solution. So these are the steps that is involved in trial and error strategy of problem solving. The best example, throwing a stone on a mango tree. We have a very famous quote. There is no harm in trying, just try. If it falls, you are lucky. If it does not, you are unlucky. What you do? You take the next stone and keep throwing it. So this method of problem solving is called as trial and error. Some of you are wondering here, what is this being taught here? Am I right? Yes or no? Is there anybody wondering why all these things are being taught here? We can have open discussion. No, I don't want to have a one-sided lecture. I can have interaction as much as possible. See, these are all systematic approaches towards problem solving. Problem solving is an important point or important area of study when you do any defined algorithms. You need to understand programming only through problem solving methods. And for most of our problems, what we are faced with, the reason why we are not able to find out solution is because we do not have a systematic method of approaching towards the problem. So you might feel that why certain things are taught which you believe that you already know or which you believe that you can do it. I'll give you a very simple example. As I told you, you know that I am involved in placements also. Once upon a time, we had a campus placement here. The company came here, they distributed so many question papers. They asked the candidates to appear and write the answers for all the questions. The first question was, Read the entire question paper before answering this question paper. And the last question was, just write your names, your departments. You don't need to answer any of these questions in between the first and the last one, and return the answer sheet. What happened was 99% of the students or candidates who participated in the drive read the first question, read all the questions I asked. Go to next. Next. There were so many other maths, so many algorithms, so many questions were there. And when they came into the last question, they've already answered many questions. They took a lot of time, and totally it was only for a 5 to 10 minutes test. They took more than half an hour or 50 minutes, except a very few students who read all the questions and who did not attempt all the questions except the first and the last one and submitted it. The problem here was they wanted to check whether you are answering all questions properly or not. Their problem was different. They wanted to understand how far you are sincere with that. Okay. So here we are studying all these things because we will be given lot of problem statements in future, and you may be asked to decide on which are the strategies that you need to adopt so that you get a proper solution for the problem. All problems what we are dealing with right now is our everyday problems and is quite familiar with you. But as we go on in the coming lectures or in the coming sessions, we may need to deal with very difficult mathematical and otherwise so many other kinds of problems. And for all these things, you need to understand the systematic way of solving a problem. So that is the reason why we are studying all these things in a scientific manner, and you need to answer all these things in your examinations. These questions are discussed here not for the sake of fun, but you have it in your syllabus, you have a prescribed textbook, and you need to study this, you need to answer this, you need to tell us how are you going to approach all these problems. So now is it clear why you are studying problem solving strategies, all of you? Is it clear? So this is all about trial and error method of problem solving. There is one more reason why these things are explained in the class. You may be asked questions, theoretical questions on trial and error method, right? The different steps involved in problem solving using trial and error method. In that case, although you know what are the steps, I am giving you the ways with which you can answer your question. Okay, you don't need to worry. You need to answer it because there will be questions based on this. Only such questions will be there in the first module, the first part of the first module. We don't have anything much in detail technically to study there. But once we start Python programming, you may be having a lot of things to learn, a lot of different things, and a lot of applications, a lot of programs you'll be doing, and so on. So the next method is the most important method. We call it as algorithmic method of problem solving. Trial and error, I told you, no, there are so many examples. Trial and error is something where you are going to try something. If it is fine, it is fine. Otherwise, it is not. So trial and error may sometimes not be possible for so many problems where we have large number of solutions. or problems where we have no idea how the solution might look like. Algorithmic problem solving strategy is more specific. You are improvising your problem solving strategy by breaking down these problems into different logical steps. Start step 1, step 2, step 3, step 4, and so on. Okay, this approach is called as algorithmic approach. Usually algorithmic approach is a step-by-step solution to a problem that could be executable by a computer. The best example of where we use algorithmic approach to solve problems is a Rubik's Cube. In Rubik's Cube, if you know the steps, you might have seen people, even blind people, capable of solving Rubik's Cube in seconds. So Rubik's Cube, what we do is that we have certain steps to be followed. We just need to follow the steps. How fast you are capable of doing these steps, so fast you can solve your problem. This method of approaching a problem, defining a solution to a problem step by step is called as algorithmic approach. So theoretical and technical definition is given here. An algorithm is a set of well-defined steps and instructions that can be translated into a form usually known as a code or a program which can be executable. So when you are given a problem and you are asked to solve this using computing methods, the first thing what we'll be doing is about its writing down its algorithm. Algorithm means what is the first step, what is the second step, what is the third step, and what is the final step, which are the steps that has to be repeated, and so on. So an algorithm is nothing but the set of the methods through which you are going to solve any problem. Initially, you might have thought that this. Do you know who won the Nobel Prize in Physics for 2024? It was announced yesterday. How many of you here have the habit of reading newspapers? Can any one of you tell me why, on what field was Nobel Prize for Physics announced? It was announced yesterday. Okay, by the next class, I'll ask you the same question. I want all of you to find it out and come. So an algorithm means a step-by-step approach towards solving problem. Most of our artificial intelligence machine learning problems are approached using different kinds of algorithms, some of which I have discussed with you in the previous sessions also. Okay, so if you have any problem, say you wanted to predict something, you want to predict the outcome of a football match. What are the steps that is being involved? The history of the players, the history of the ground, how people have been playing in this ground, what are the possible results, not football, it can be cricket or anything of that sort. For all these problems, what we do is that we break it down into steps and we systematically divide these steps into different stages and execute these things stage by stage. So Algorithm is a set of well-defined steps and instructions that can be translated into a form which is otherwise known as a code or a program that is executable. So examples of algorithmic approach towards problem solving. First one I told you instructions for how to solve a Rubik's cube. The next one is cooking a dish is given in your textbook which is shared to you in PDF format. Cooking a dish. First of all, if you want to cook a dish, the step one, what you will do, you will collect all the ingredients, right? Second step, you will take it in its proportion. And third one, you will start heating it, boiling it, or whatever it is, or use an oven or something. The example given in your textbook, I think it was about baking a cake. So when you want to bake a cake, what you do? You initially collect its ingredients, preheat the oven, mix it in the right proportion, keep it in the oven for the particular period of time, and then make it ready to serve. So this is an example where you need to apply algorithmic approach of problem solving. Next is a very important application, computing applications. There are two important computing applications that come very often in your, or that come very often. One is the searching operations and the other one is the sorting operations. Suppose you search for a keyword in Google, what happens? What kind of algorithm works out here? There would be different kinds of searching algorithms like quick sort, quick search, binary search, sorting algorithms, quick sort, binary sort, and so many other kinds of sort. Suppose you are given 10 numbers or 3 numbers, let me take. I'm giving you 3 numbers, for example here, five, I am asking you to sort out these numbers 5, 9 and 3. I want you to arrange this number in an increasing or a decreasing order. I want you to sort this out. Can any one of you here give me an algorithmic explanation of how you are going to sort this out? A scientific way of approaching towards this would be you compare 5 and 7, 9. Right? You want to arrange this in an ascending order. 5 and 9 you are comparing. 5 is less than 9. So if 5 is less than 9, swap it. Then what happens? The next stage will be 5 is already less than 9 and it is in the right position. There is nothing to swap. Next, what you will do? You will compare 9 and 3. So 3 less than 9 or 9 is greater than 3. So what you can do is that you can swap these two things, right? So the next step will be 5, 3 and 9. Again what you do? You start from 5. Compare 5 and 3. 5 is greater than 3. What you do? You swap this. So 3, 5, 9. You get. Again what you do? You compare 5 and 9. It's fine. 5 is less than 9. So you repeat the steps until you have nothing to swap. So you have done a very simple sorting algorithm. Similarly, you have search algorithms also, wherein you can search for an item in a group of items. How your search engines work. It is kept in a sorted fashion. You have keywords kept in sorted fashion, and Each and every point wherever you have given the keyword is being selected. It is checking whether the keyword is above or below, goes to the next, and so on. This is how searching is being done. So, in algorithmic approach of problem solving, with respect to computing, you can give very two good examples, sorting and searching. Apart from that, real-time examples which is given in your textbook consists of all what is mentioned here. The third approach or the next approach is called as heuristic approach. Heuristic technique of problem solving depends upon your mental shortcut or rule of thumb. Is any approach to problem solving that is not that employs a pragmatic method that does not have any kind of systematic rules or regulations, and it has to be done in this manner, nothing of that sort. How your intuition works, how you think it works, that way you apply, you call it as heuristic approach of problem solving. It depends upon your mental shortcut and things like rule of thumb and so on. It's it's mostly used in very quick solutions. It depends upon your sense of understanding of the problem, wherein how your mind gives you the right answer, you go according to that. This approach is called as heuristic approach towards problem solving. So the next method of problem solving is called as means end analysis. What is meant by means end analysis of problem solving strategy? So in means end analysis, what we are doing is that we are considering a big problem, we are breaking down into pieces and addressing each of the small modules or small bits so that we can achieve the final goal. Okay, this method of problem solving is called as means end analysis. So for example, let us consider an example. This example is taken from your textbook itself directly. Suppose you want to go to Kashmir from Trivandrum. So what are the steps that you are going to take? So we are going to plan according to our goals. Okay. So let us divide this process into different kinds of steps. So in this example, In this example, we would like to analyze how we are going to use means and analysis so that we want to solve the problem of how we are going to travel from Trivandrum to Kashmir. So here we are defining our goal, we are identifying the problem of our travel. Your ultimate goal is to travel from Trivandrum to Kashmir. For example, this is our first step while we are doing mean and analysis of a problem. Okay, so first we have defined the goal. Second one, we'll analyze the current state. What is that you are doing, where you are, and what are the things that you need to do, what is the mode of travel, and all these things. Then we'll understand the distance. What is the distance from the point from Trivandrum to Kashmir? We'll make it out. What is the number of kilometers? So how you are going to break this down into sub problems. Okay. So let us consider that while using mean and analysis, we have defined the problem first, we have identified the problem first, then we have defined the current state, what we are supposed to do right now. Second thing is that we have find out what is the quantitative step that we are going to take. How much is the distance from Trivandrum to Kashmir? Then what we'll be doing is that we'll be defining sub goals. For example, we'll define the places where we are going to stop for fueling, for lunch, dinner, breakfast, etc. Okay, per day how many kilometers you need to travel so that you comfortably reach the destination. How many kilometers you go, then which is the best route that you have to adopt so that you reach in time. Okay. So here we are defining the sub goals, where all we are going to rest and what we are going to do and all these things. Okay. Then we'll plan the route. Next is the action. Implementing the drive. You are starting from Trivandrum, you are going to Bangalore, Karnataka. You are going to refuel in certain places. You are going to plan your overnight stay at one particular place. The next place, the next target, you wanted to visit. If at all you wanted to go through all the cities, major cities like Hyderabad, you want to refuel at this particular place, you want to stay at this particular place, and all these things may be divided as sub points. These are all examples, okay? You don't need to work too hard to find out the exact things, but these are all examples. Okay? So the next continuation of this, what is the next part? The next, where you are going to stay, the third day, where you are going to refuel, where you are going to have your lunch, breakfast, or dinner, and all those things. Planning all those things and keep moving like that till you reach Kashmir. Here you can write these steps according to your imagination or your plan. Okay, what are the initial steps? But one thing you have to remember, that everything happens by dividing one goal into another. Okay, subdividing the entire problem into much. How many of you have heard about the Tower of Hanoi problem. I'll just show you that here. Okay. You have 3 disks and 3 poles. You need to transfer this pole from here. This is, let us call this A, this B, and C. You need to transfer this pole, these disks, from A to C in the same order, but you can take only one disk at one particular time. Okay. Listen to my question very carefully so that I'll ask you a question after this. The conditions are like this, that you cannot take this without taking this. You cannot take the bigger disk without taking these 2 things. First condition. Second condition is that you can take only one disk at one particular time. These things are disks, okay? And you cannot take all these things abruptly. So minimum how many steps would you need so that you can transfer all these 3 things from A to C? This problem, or this is a very common thing called as Tower of Hanoi. Who said 6? 10. No, 6 is a better close answer, but still 6 is not right. The minimum number of steps that is required is 7. But how? How are you going to solve this problem? Step 1, what you will do? This is here, right? This is here. The least number of steps with which you are going to transfer all these disks from A to C. That is what we are going to see. This is a very famous problem known as Tower of Hanoi. You can search in the internet for that and you will get more details on that. So I'm taking this and I'm keeping here. This is step 1, right? Yes. What will be step 2? You cannot keep a bigger disk on the smaller disk. What will be step 2? In step 2, what we'll do is that we'll take the second disk here, this yellow one, and we'll keep it here. Step 2. Step 3, what we are going to do? This Tower of Hanoi problem is explained in your textbook. Step 3, what we'll do? This one, now, this we have transferred here, this green color disk. This we'll keep here. Right? This is step 3, right? Now step 4, what we are doing? We are transferring this here. Okay. Step 5. I am taking the smallest disk and keeping it here. Step 6, I am putting this here. Step 7, I am taking this and putting it here. So I've transferred from A to C in 3. These 3 disks are there, no? 2 raised to 3 minus 1 is the formula. 2 cube is 8, 8 minus 1 is 7. So you require 7 steps to solve the Tower of Hanoi with only 3 disks. If you have 4 disks, it becomes 2 raised to 4 minus 1, that is 16 minus 1, 15. Is there anybody in this class who did not understand the Tower of Hanoi problem? You understood, no, all of you? You have 3 rods and 3 disks of 3 different sides. You have, in the first one, you have biggest one in the smaller, down. Above that, you have the next one. You are asked to transfer from A to C all these 3 things. How are you going to transfer? In this, conditions are like this, that you can transfer only 1 disk at a time. You cannot keep a bigger disk above a smaller disk. Okay. So you are transferring from A to C. This requires minimum of 2 raised to 3, that is 2 cube minus 1. 8 minus 1, that is 7 minimum steps. Is that clear? You can refer this again, or you can just look into your textbook, or you can search in Google for Tower of Hanoi problem. You will get this problem and its explanation very clearly given. Okay? Is that fine for all of you? Is there anybody in this class who wants me to explain this once again? I can do it again and again till you understand. No problem for me. The next and the last problem solving strategy that we are going to study is called as backtracking. Backtracking means you have a solution, you are going from solution to the problem. Okay. So here what we are going to do is that we are going to say the best example is Sudoku. How many of you are fond of playing Sudoku? Raise your hands, no? I am very much interested. I enjoy playing it whenever I get time. So you have mobile apps where you can play Sudoku. That means you can always keep trying with n number of numbers. You can check whether the numbers work from back to front or not. This process of problem solving strategy is called as backtracking. So what are the important steps, or what are the important strategies that we have learned today from morning to now? I'll give you a small recap of all the problem solving strategies. First one is trial and error. We have seen different steps adopted to make trial and error solve a problem, right? Second one is the algorithmic approach, how you are going to write it systematically using steps one by one. Third one, heuristic solutions. Heuristics means what? What do you understand by heuristics? Rule of thumb, or what do you say? Intuition, how your mind is going to work, what your mind is going to give you an idea. That's the third method of problem solving strategy that we have studied. The fourth one is just now we have seen what is means and end analysis, and the fifth one is backtracking. going down from the solution to the problem. We'll be analyzing the list of possible solutions, and from there we'll go back. Examples of trial and error I've given you: heuristics, baking a cake, algorithmic approach, baking a cake, or solving a Rubik's cube. Heuristic examples: means and analysis, traveling from one place to another. What are the things that you have to do? Fifth, the last one, backtracking. So these are the points that you may need to write when an examination question appears in your exams. So thank you all. Thank you for listening to me. The next class, with this we have completed the first part of our first module. You might get questions based on problem solving strategies, what is meant by heuristic approach, what is algorithmic approach, what is problem solving as such. Give everyday examples of everyday life where you need to address different problems and so on. I'll share with you the model question paper and sample questions. Along with that, I want you to prepare the answers for these sample questions also. The next class, what we'll be dealing with is, we'll start studying about computer as a model for problem solving. Why algorithms are so important. So the next topic is computer as a model for problem solving. After that, coming Monday, I just wanted to repeat it. In our lab session, I'll be giving you the introduction to Python programming using Google Colabs and Spider. I'll teach you how to use IDLE also. IDLE is another Python integrated development environment. I'll teach you what are variables in programming languages. Data type, strings, and print statement. Okay. So next class. So we'll meet in the next class.